God, if we get through this, it'll be a freaking miracle. All right, now, anyway, sorry about that. Okay, so if the capacitors are in series like this, then the charges are the same on all of them. And so all of this charge builds up right here, but the voltages are different. Okay, the voltages are different. So what does that look like? Well, so V, so this is for when they're in series, capacitors in series. So V is equal to V1 plus V2 plus V3. Now where am I getting that V1, V2, and V3? It's right here. Looky, looky, looky. There's a voltage difference between, there's a plus minus, plus minus, plus minus. So there's our V1, V2, and V3. Well, what did we say that V is equal to? V is equal to, Q over C. Okay? So this Q is the same in all of them. All right, so Q1, Q2. So the total Q, this Q right here, if we added them all together, is still equal to each of the charges in there. So here's what we do. We've got, this is Q over C total, and V1 then is equal to Q over C1 plus V2 is equal to Q over C2. Now, where am I getting that? Remember, Q is equal to V times C. So if I'm solving for V, if I'm adding up the V's, it's Q over C plus Q over C3. So therefore, 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Okay? Then to find C total, it's equal to 1 over C1 plus 1 over C2 plus 1 over C3. You add all those up and then take the inverse of it. Okay? And a curious thing is that we're going to find in class on Friday, tomorrow, is that the total that we get here is less than the smallest one of these. Okay? It's less than the smallest one of these. Now, what about when I have these guys in, what we call parallel? Now notice, if I'm a charge sitting here, I can get to the battery easy peasy without having to go through another charge. That's what we mean by it's on in parallel. All right, so if I'm sitting here, if I'm a charge sitting here, I go, oh, can I get to the battery? Yeah. So that means these guys are all in parallel. Now what's going to happen here is the voltages are all the same, not the charges. In other words, Q1 plus Q2 plus Q3 adds up to the total charge that's on this plate, all right, that's on that plate. So when they're like this, then since, once again, in parallel, we're going to find out that next week, we're going to find out that resistors act just the opposite. In parallel, then, I've got Q total is equal to Q1 plus Q2 plus Q3. And so since we know that Q is equal to V times C, and the voltages are all the same, okay, make sure you understand that if this is 12 volts, guess what? The voltage between here is 12. The voltage between here is 12. The voltage between here is 12. In this case, if this is 12 volts, and let's say the capacitors are all the same, this could be 4 volts, 4 volts, and 4 volts. Or if the capacitors aren't the same, this could be 5 volts, 2 volts, or 5 volts, 3 volts, and 4 volts, or something like that difference. Okay? So we get them all in a line like that. Then it becomes a snap. Q total becomes, this is equal to V times C total, which will give me, sorry, I'm losing my mind. V times C1 plus V times C2 plus V times C3, and then divide out my V. That's supposed to be a C total there. I couldn't read my writing. I was going, is that a G? No, it's C total is equal to C1 plus C2 plus C3. That's when they're in parallel. Okay? So I'm going to stop here, and I'm going to do 2 problems, and then we'll call it a day. I think we'll finally have gotten there.